Hello, okay, we're going to go over IB biology data analysis, just some basic data processing, and then a more sophisticated statistical test. So some of the basic data processing that you should be able to do just using Google Sheets, for example, or maybe Excel, is to find the mean or average of the trials of your data. Okay, this is going to be useful for creating graphs that synthesize your data so that your graph has the average of your trials, not each little data point from all of your trials. Okay, we care about the overall bigger picture of the results of your data rather than sifting through all of the tiny details. Okay, median could be another basic data processing tool that you use. Standard deviation is something you'll definitely want. Okay, that's going to be useful in analyzing the spread of your data in your different trials, and so that's going to be useful when you're doing your evaluation section and talking about the precision and accuracy of your data based off your standard deviation and how that may have affected your precision or accuracy of your data and how that could affect the validity of your data. Okay, and then percent change is one that's often overlooked that could be really useful to show changes between measurements from one treatment to another, or maybe percent change from the beginning of or of your sort of first treatment, or maybe from your control treatment to some final treatment, or like your biggest sort of treatment, maybe. Okay, line of regression is another one that you could use where you end up with the equation of the line and you can look at the slope of that line to indicate a strong, medium, or weak correlation between your independent and dependent variables. That can either be positive or negative. And then finally, there's the ANOVA test, okay? And this gets a little bit more complicated, so we're going to go into the details of exactly how to do this. I'm also going to show you how to do line of regression, and standard deviation and mean are pretty easy, and percent change as well. So let's take a look at these. Here I have some sample data that I've just made up, but it's based off of these 5 different treatments. Treatment 1 would presumably be your control group. Okay, this is the group that you would be comparing to your other treatments. Okay, instead of putting treatments for your data, I would put whatever your independent variable is. So maybe it's different concentrations of salt solutions, for example. Okay, then you would have these 5 different trials because it is supposed to be 5 trials by the 5 treatments, 5 by 5, so that you have a good amount of data that you've collected and also a good amount of different treatments that you've collected, which is just going to increase the validity of your data and your experiment overall. Okay, so you've got trial 1, trial 2, trial 3, trial 4, trial 5. Notice that I did include the measurement error here. I put centimeters plus or minus 0.05. Okay, so that's something important to note. You definitely want to include your measurement error or you're going to be losing points on the IA. So if this is your data, instead of doing a graph of all of your different trials of data, you're going to want to just do a graph of the average of each trial for each treatment. Okay, so how are you going to do that? Well, I did calculate it over here, so you can take a look. I took the average of this treatment 1 over here, okay, throughout these 5 different trials, the average of that using this equation in sheets. Okay, then I just dragged that down and it applied to all of these other ones over here. If you want to see what the standard deviation formula looks like, you'll just press equal. STDEV is the formula for standard deviation, and you're going to be calculating that for each of your treatments and all of the 5 trials of the different treatments. So the standard deviation for that first treatment, the control group, was this, okay, as you can see it over here. And you would just do that for each of your different treatments. Okay, average percent change in growth, if you wanted to know how to calculate that. Now, I calculated the percent change in growth from trial 1 to trial 2. So obviously you can't do it for this one because there would have been no change at that point because that's the first trial. So here you just take trial 2's average growth minus trial 1's average growth divided by trial 1's average growth times 100, and that's going to give you the average percent change in growth. And then you can, again, just drag that down, and it would apply to all of the other ones there. So that's 94% average change in growth there. Okay, now that we've got all of those basic calculations out of the way, let's get into how to do a line of regression. So if you highlighted your average growth for all these different treatments, then you could insert a chart. I would suggest making that chart a little bit better by fixing some of these axes on here. So let's see. So for example, chart and axes, go to chart title. You're going to want it to be way more descriptive than it was before. So effective salt concentrations on average stem growth, and then always try to include that measurement error there. And then also always try to include your species name that you're dealing with, if you do have one. Okay, we're going to change this a little bit to make it a scatter plot. Scatter. Okay, customize further. So those treatments on the horizontal axis title you can change over here, and I'm going to put the label salt concentrations. And of course, like I was saying, you would want, instead of treatment 1, treatment 2, treatment 3, just put the concentrations of salt that you would have used over there. Okay, besides that, what you're going to have to do next for the line of regression is go to series. Then you click trend line, data label, and show R2. And so that's actually showing us the slope of that line. So it's a positive slope. Closer it gets to 1, the stronger the correlation would be. Okay, so that's how you do line of regression with graphing in sheets. And now we're going to get to the tricky part, which is ANOVA. How do we do the ANOVA? Oh, one other thing that's definitely worth noting, you do need to know how to do the error bars for standard deviation. Okay, so if we have our sample graph over here, actually, let's just start off fresh and make a completely new graph. Step 1. So you're going to take this data, and yes, this looks a little bit weird. You have to take your averages over here and just place them in different columns for each treatment that you had. Once you have that done, highlight it, press Insert, Chart. Okay, we've got our chart here. We're going to customize it a little bit. Okay, you've got to change your chart title to something more specific. Change your horizontal axis to something more specific as well, so the salt concentrations. And then also you're going to want to make sure that the vertical axis is changed. Okay, so this is average growth. There we go. And now, again, we're trying to insert these error bars for standard deviation. So what you're going to have to do is first highlight this first standard deviation number, go into the settings, okay, go to customize, go to series. Okay, you have to select this column 1 series, which goes along with treatment 1. Scroll down, click on error bars. Instead of clicking standard deviation or percent, you just click constant and you're setting it as your own constant. And now you can see the error bar has shown up there. You're going to do the same thing for all of the other ones. It's a little bit annoying because you do have to each time go back to series, select the series, in this case it's the red one, column 2, click error bars, put it in right there, and now you can see you've got your standard deviation. Go to constant. You've got your standard deviation right there as well. And if you want to show the data label for that, you can do that too. You just click data label right there. So you just go through each of these different treatments and do the same thing for each of them.